Good morning, everyone. As per usual, we'll start off with a homework quiz. So here we go. What I want you to do is create a set of 10 numbers such that the median is 9. There are 2 modes, and the mean is not equal to the median or the mode. Okay, so it can be any 10 numbers, but those are the rules. And please include some notes or calculations that show this is true, right? Tell me what the mean is that proves that it's not equal to the median or the mode. Okay, so we'll work on that for the next 3 or 5 minutes. So if whoever's running this, you might want to pause the video, and when people have handed it in, I'll be ready to move on to the note. Alright, so we're back now. So for today's note, we're talking about what's called measures of spread, and we'll get into what that is in just a moment. But this is how I'd like you to kind of warm up a bit. So here's the following sets of results for 2 professional bowlers. We'll call them Kenny and Spenny just for fun. So there's Kenny's scores, and there's Spenny's scores. So the question is, if you had to pick Kenny or Spenny to be on your team, who would you pick? Okay, and I would like you to try to provide some mathematical reasoning for this, right? Not just because Spenny's name is cooler or something like that. So take a few minutes now, okay, maybe discuss with your group, maybe do some calculations, and try to determine who you think the better player would be. So again, probably pause the video for a few minutes here while it's going on. Okay, maybe even have a little class discussion, and then we'll kind of go from there. All right, so if we're back now, just a couple notes from my end. Okay, hopefully, in talking about this, you did some of the number crunching. Okay, and you may have noticed, okay, that if you calculate the mean for both of these players, the mean comes out to be 193. Okay, and if you check the median for both of them, okay, they are both 192. Okay, and we only have 6 scores, so not surprisingly, there's no mode for each player. So based on that, okay, you might be tempted to say, well, mathematically then, they must be the same player, right? They have the same average, so they are the same. Of course, when we look at this as scores, that's not really true. Again, I don't know what you had in your discussion, but some people may have pointed out the idea of consistency, right? Kenny's scores are all pretty close together, right? They're close to the 193 average. Whereas Spenny's scores are a little more all over the place. He does have some really high scores, and he does have some low scores as well. So, okay, it depends what you're looking for. If you want consistency and want someone who gets kind of the same every time, okay, you're going for Kenny. Okay, if you want to have the opportunity to get a really high score, right, with the risk that there's a low score, you might want to pick Spenny. Okay. But mathematically, we can try to capture this idea of how spread out the data is. Okay, so we're going to go talk about a couple different ways you can do that. So the first one is what's called quartiles, interquartile range. Okay, so the purpose of quartiles is just to break the data up into 4 pieces, right? So we already know the median is the middle of the data, meaning half the data lies above the median, and half of it below. Okay, quartiles is just breaking it up into 4 equal-sized pieces. So for an example, this following list is a set of test scores from a grade 9 class I had the very first year I was teaching here. Okay, so we're going to go through the process of how you find the lower quartile, the median, the upper quartile, and the interquartile range. So here are those scores. So again, this might want to pause for a minute to make sure people are caught up, and then we'll continue. We'll start with the median, right, which will be the halfway point here. Okay, and there are 20 numbers in this list, so if I count in 1, 2, 3, 4. Okay, the median would end up being right here, okay, halfway between 44 and 45. Okay, so our median is going to be 44.5. That's the middle point where there's equal amounts above and below. Okay, to do your lower and upper quartiles, really all we have to do is do median again, right? So lower quartile is the median of the lower half of the data. So I go through my new set. I've got 10 numbers, so my middle point will be right there between 38 and 42. So that means that my lower quartile is going to be 40. Okay, and the upper quartile, so halfway between these lists, or that set, is 49. Okay. Finally, the difference between those two things is what we call the interquartile range. Okay, so again, just the difference from here to here is 49 minus 40, which gives us a total of 9. Now, part of the reason we do this, if we go back to a couple lessons ago, the overall range of this data, so from 6 to 59, okay, the overall range is 53, which is, considering it's out of 60, is pretty much the whole thing. You might think, uh-oh, these scores are really spread out. Okay, but, okay, the distance from here, right, 40, my first quartile, to my third quartile, okay, is only 9 points, and that's half the class, right? So half of this data is actually very close together. So as a whole, it's not as spread out as it might first look. Now, this information here can also be used to create a box and whisker plot, okay, which is that funny chart we had a couple days ago. So I'm going to briefly show you how that works. Okay, so in terms of our scale, in this case, 60 is a good reference point because that was the highest possible score. Okay, so to make a box and whisker plot, there are 5 numbers we're going to plot here. The first one is the lowest number. So if I go back to my list, the lowest number on the list was 6. So I'm going to make a dot roughly where 6 would be. So my scale is not perfect here. That's supposed to be 30 and about halfway. So maybe 6 would be about there. Okay, the next point I'm going to plot is my lower quartile. And that was at 40. So my next point is going to be about here. Okay, my next point is my median. That was 44.5, which is right about here. Okay, my fourth point is going to be the third quartile, and that was 49, so just a little bit further. And my final point that I'm going to plot is the highest number in the list, which I believe was 59. So that's going to be right up here. Okay, to complete the graph, okay, for the first quarter and the last quarter, I'm going to draw some lines. And for the middle section, I'm going to put in some boxes or some rectangles. Okay, and that is how you create a box and whisker plot. Okay, again, visually, that idea we just talked about with the interquartile range, right? Half my class is right here, and they're very close together, and they're right around the median. Okay, so it's all really bunched up. Okay, and again, a quick glance shows that 3/4 of this class, if I'm looking this way, 3/4 of the class is about 40 or better, which is like 60s and higher, I think, on that scale. So that's really good. Okay, the other type of measure we're going to look at is what's called variance and standard deviation. Okay, specifically, we're going to mention variance, but standard deviation is the one that we're really going to focus on here. Okay, this is the more important, I think, of the two. Okay, personally, I don't know, through my math experience, we talk a lot about this one, not as much about this one, but they're connected. Okay, so what they're trying to measure is really the kind of the average distance from the mean. So another way to think about spread is, okay, if I know what my average is, how close is the data to it on average? Okay, so the formal definition for standard deviation, and the symbol we use for this is a lowercase sigma. Okay, here's the formula. So sigma is equal to the square root of the sum of each piece of data, subtract its mean, squared, and then average, so divided by n. Okay, so like with the formula I saw yesterday for mean, okay, we'll go through the context and I'll show you how to actually calculate this through. Okay, so to show how this works, we're going to do the calculation for Kenny's scores. Okay, so the mean there was 193. So again, you might want to pause here for a moment to let people set up the table, and we'll go through how this works. So going back to that formula, we had, right, it's the sum of, so this first part in the brackets, x minus x bar. So that is x minus the mean. So I'm going to take all the data I originally had and just go through and subtract the mean. Okay, so I did the first one on here already, right? 190 minus 193 is negative 3. So for 189, okay, take away 193, that is negative 4. For 196, it's 3, and so on. It's 11. That is going to be negative 8 and 1. Okay, so now kind of following bed mass. The next part of that formula was to square those. So I'm going to take each of the numbers I had here and just square them. So 16, 9, 121, and so on. So now, to average them out or calculate the mean of this list, I'm going to add all of these up and see what I get. And actually, just bring up my calculator here. Missed one of the 9s. Okay. Okay, so my total is up. I get 220. Okay, so now we'll calculate the average for those. So we'll divide that by 6. Okay, and I get 36.6 repeating. Okay, and finally to get sigma, okay, I'm really just taking the square root of the previous answer. Okay, so I got 6.055, so that rounds off to about 6.06 approximately. Okay, so my standard deviation is a little bit over 6. Okay, so that's how you calculate it. Okay, what is this really saying? So what this is capturing is that if I go back to my list of scores, which again I guess is right here, okay, most of my scores are within 6 points of my average, right? So my average for Kenny was 193. Okay, and if I go 6 points below, that would be at 187. Okay, and if I go 6 points above, that would be 199. Okay, and if I look at my list, okay, of the scores I have here, right, 1, 2, 3, 4, so 2/3 of them are within 6 points, and the other third is outside of that range. Okay, now again, this is a very small list. But as the list gets bigger and bigger, that's the idea we're trying to capture, is how close to the average is that data. Okay, so again, to summarize that, okay, standard deviation is 6.06, so most of his scores will be within about 6 points of the average. Okay, so to compare, we're going to do the same thing for Spenny's, okay, but instead of doing it by hand, I'll show you how to do it with a graphing calculator. Okay, and actually the process is pretty much exactly the same as what we did the other day. It's in that list of calculations. So once the calculator is clear, so I'm gonna, my calculator cleared when it started up here. Okay, if I go into edit and I go into my list, we're just going to grab Spenny scores and put them into the calculator. So we had 257. And again, I think the graphing calculator should be in the room. So if you don't have them already, and you might want to pause and let everyone catch up to this point so they can try it. Okay, so I put the numbers into the list, and now I'm going to go back to stat and scroll over to calc and pick out one of our stats. Okay, and when I run that through, okay, you can see that sigma is right here. So for Spenny, whose scores were more all over the place, his standard deviation is 43.39. So most of his scores are within 43 points of the average. So again, a lot more spread out. Okay, so yeah, Spenny's is a lot higher, so that idea of consistency. Okay, Kenny's standard deviation is way lower, so his scores are much more consistent. They're more close to the average. Okay, in the next few days, we're going to be focusing a lot about standard deviation and how it shows up in certain distributions. Okay, so that's it here, and I'm going to cut number 12, I think, out of my list. Okay, but these are the questions I would like you to do for practice. Thanks for watching. Have a great day, and I will see you hopefully tomorrow.